Okay, great. Awesome. So, ja, welcome to today's lecture in ESP, Einführung in strukturierte Programmierung, or Introduction to Programming. Yeah, I'm really happy to be back in Graz.
Yeah, me too. So we can sit next to each other.
Yeah,
it's more comfortable for us both than doing this remote. Hello also from my side. And what do we do today? We're in week 2.
We're in week 2, and that's great because we have already talked about data types, we have talked about variables, and today we will talk about structs and also how to control the flow of our programs. For that, we will introduce conditions and loops. Yeah, that's great. But before we start with the actual content of the lecture, we have a few organizational matters. The first are coding sessions. The first coding session block started this week, and maybe some of you have already participated in the coding sessions. We hope you enjoyed it. And just to give a brief overview about the procedure of the coding sessions again, please register for a session if you want to have the points for the coding sessions, then complete the homework, and please submit it before the coding session, not afterwards, because otherwise you won't get any points. And once you've done that, just attend the session, participate in the discussions, and at the end you can earn up to 4 points for the coding session. So that's the first thing. The second organizational matter are personal question hours. We offer personal question hours for you to have the opportunity to ask questions, especially in the beginning related to the virtual machine, about repositories, Git, or whatever. So we really think that this is a great opportunity for you, but there is one important thing. Please deregister in time once you know you won't be able to attend the personal question hour you have booked via Teach Center. This is unfortunate for both students and also for our tutors that are there in the personal question hours. So as a consequence, if you do not deregister in time, we may block you from further personal question hours. So really please deregister once you know that you won't be able to attend. Is there anything else organizational wise?
I think that's all. But the chat is very, very silent. So if you are there in the chat, if you can see us, hopefully we are really online. If you can see us, please give us whatever you want to write in the chat, that we also know you are there and we are, yes, okay, it's working, yeah.
Very good.
The silence was a bit strange to me, but now it's working. Great, okay. Now I got the feedback. All right, should we start with a short recap? What we have done last time? And I think it's already time to get you involved. And you can scan this QR code or go to slido.com and enter this code you can see on the left side. So we have a few questions there about what we have done last time and maybe what you also saw in the practicals today. The first question is you should mark all the correct descriptions of the data types written there. So maybe in the meantime, we can answer a few questions from the chat.
Yeah, that's great.
So you're not automatically registered to public questions, are you? No. So the thing is, you have to register for a public question hour if you want to participate and join. But some people registered, but they didn't come, and that's unfortunate then because we are waiting for you. So if you register and then you found out that it's not possible for you to come, then you should please deregister because otherwise we are waiting for you. And that's a problem for us because we are basically waiting at the lecture hall for you to come, and when you're not coming, it's frustrating for us.
Yeah, also for other students that would have liked this one particular slot and they weren't able just because one registered but did not come. So it's unfortunate for both students and us.
And you can register in the Teach Center. So there's an own section. Maybe we can open this in the meantime. Some of you are still doing the thing. So we have here, where is it? Personal question hour. Here's a scheduler, and here you can participate for the personal question hours. All right. We have around 100. So I think let's look at the results for this one. Yes, many did most of the things in a good way. Great. So float are numbers with decimal places. Yeah, that's correct. Characters are for single characters. That's also correct. An integer is a number with and without decimal places. That's not correct because integer only can handle numbers without decimal places. Then doubles are big numbers without decimal places. Yeah, the double is thought to be for big numbers without decimal. Isn't it? It's wrong.
It's wrong.
It's wrong. Yeah, I'm sorry. I just saw it. A double is for decimal places,
They
basically.
definitely have decimal places.
Yeah, it's wrong. My fault. I'm sorry. That's why it is so. Yeah, now it's going down again. Okay. No, it's wrong. I'm sorry. It's for big numbers with decimal places. Yeah, and the long on the last one here is for long sentences. No, that's wrong. The long is actually for big numbers without decimal places. Sorry for the confusion, but you can see on the distribution of the correct and incorrect answers now what's correct and incorrect.
It's already indicated that it might not be correct.
Yeah. I'm sorry for that. Let's try another one. The second example. I think you also saw a similar one in the practicals. Let's see if you can remember what's the problem here or what's the output in this case. Yeah, I was also questioning my life. Yeah, I'm sorry for that.
Me too.
Yeah. Okay, so we have a character, a variable of a character. We write a inside. And then we add 2 in the second line to this character variable and we print it out. What's the output? Okay, let's give you a few more seconds. Maybe one question in the meantime. Should we learn the ASCII table? No, of course not. If there is a question, for example, in the exams, there is always an ASCII table on the other side. So you have it there. It's not necessary to know. But the more you work with it, the more you're getting used to the numbers, and you will see that some numbers will burn in your mind.
Yeah, definitely.
All right, let's continue with this one. What's the solution? Yes, it's C. It's C. Most of you did it correct. Great. Why is it C? Maybe a short explanation. I have the ASCII table here on the right side. So we have the A character and it's 65. We add 2 to it, so it's 67. What we do here is we want to print the character, and that's why the output is C. In contrast to that, what would be the output here? Maybe you can write it in the chat.
Yeah, this looks good.
The output in this case would be 67 because it's the same variable here, but before here we are printing the character and here we are printing the digit. So in this case it's 67. That's the whole magic behind that. All right. That was already the recap, and we would like to introduce something what we already wanted to do last time, but unfortunately we talked too much and the time was too little in the end. So we want to talk about the size of variables in general. We have seen something like this last time, and there are different data types and the usage for it. And here on the right side, we saw that depending on the data type, they consume different amount of space in memory. And we want to focus now here on the character. So this is interesting for us. It's just one single character. It's often used for representing the ASCII tables, and it consumes 1 byte. So what this means is it's 1 byte, so 8-bit, and it can show 256 different values. I tried to print them there. Of course, not all of them is space for it, but it's starting with 0 and it ends with 255. So altogether, 256 different values can be represented with that. The question is now, what happens with bigger values? And maybe we can go to online GDP and I just enter this into online GDP. I have my hello world here, and yeah, of course it's not formatted. What do you think will be the output? I have here a character X and I write 256 inside. So let's remember, we only did the biggest number is 255. What could happen now? Maybe our computer breaks.
I really hope it doesn't break.
I hope, yeah, because we are streaming on that. What actually is the output? Okay, it says that there is a problem, yeah, it recognizes it, but the output is, in this case, 0. That's interesting. Why does this happen? You can imagine that like a clock. I've represented it here, and when you have the numbers 1, 0, 2, 4, and so on, and you are on the biggest number, in this case 255, and you add 1 more, then you are at 0 again, because you cannot go out of this clock. It's just impossible. So we call that an overflow. So when you're on the highest number and you add 1, you're on the lowest number again, and that's called an overflow. We can also do that in the other way around, which is then called an underflow. So if you have 0 and you decrement it, so you reduce it by 1, you will end up by 255. So you cannot break out of this circle, of this clock, and that's very important because you have to think before your program, is this really the appropriate data type? Because when I know my number is going to getting higher than 255, the character for 1 byte is probably not the best choice, because you will never get higher values than 255. And maybe you can ask now the question, how can we represent negative values? We just saw all the positive values and it was like that. And this is called an unsigned character in this case. Unsigned means there is no sign before the number, so it's always positive values. You cannot have negative values. This is what we assumed also in the last example there. In general, when you create a variable, it's not unsigned, it is signed. Signed means you have half of this value range are positive values, and half of them, the left part in this case, are negative values. But what you also can see here is now we have only half of the positive values. When we go back, we can go to 255, and in the signed variables we only have 227, and the other half is reserved for the negative values. That's also interesting. When we go back to the online GDP And let's say we have here an unsigned char -1. What do you think will happen now? Maybe you can write your guesses in the chat. So we have an unsigned char here, so we have no sign, but we say it should be -1. Yeah, now the compiler doesn't even know it, so we do not recognize there's a problem, but we get out 255. So we were here, it's an unsigned, we have this 0, or let's say -1, it's one step to the left, so we end up at 255. Another example, what do we have when we have a signed character x and we put in 128?
I think there's a small typo. Yeah, exactly. And I'm really curious what will be the result here.
So let's go back to this clock. Maybe it helps you. What would be the output when I have a signed variable and I put in 128? Oh, that's the wrong one. So, okay, so let's execute it. And we get -128. Why is that? Yeah, we have here the right section for positive values, but it only goes until 127. When we take 128, we are basically at this value here, and this is already on the left side of negative values. So we kind of broke it.
Somehow, yeah.
Yeah. So what you should remember is when you have signed variables, it's always just half of the address space of the values you have.
This means we have, for example, in the unsigned universe, we have this specific space 0 to 255, and then once we add a sign, so negative numbers, it transitions to 127 and goes back to the negative number -128.
Yeah.
So just a transition of the whole space into the negative universe. Let's see.
Exactly. And this happens basically for all the data types. So what you have seen now is the character. We have a range from the unsigned from 0 to 255. But if they are signed from -128 to 127.
Just one quick question in the chat. So there's a -128. Why is there no positive 128?
It's a question for me or in the chat?
It's a question from the chat to you.
From the chat to me.
Yeah.
Because we only include the 0. And the 0 is...
So
we go back. Yeah, the 0 is here counting as the positive value.
Okay.
And when we have here the complete opposite, it's the minus value because this counts already for the positive values.
Perfect.
Yeah, but this also is applicable for other data types. For example, for the integer, of course, the range is much bigger. We have now a size of 4 bytes. And the range for the unsigned is from 0 to 4 billion and a lot of millions, yeah. And in the signed range, it's from -2 billion to +2 billion, yeah. So if you have a number which should be always in this range, it's fine to use the integer. If you know that your number will exceed that again, maybe you should then consider taking a long, because a long variable has 8 bytes, and I cannot say what this number is. I'm sorry. Even I wouldn't be able to say it in German as well. But it is a huge range you have here, and I've never experienced that I have anything where I need a larger number than
Yeah.
that.
I also haven't exceeded this number yet.
Yeah.
So
You have also a signed, unsigned ranged here and a signed ranged. So this will definitely do the job if integer might be too small for that. And we also have this for floats, also for floats and doubles. It depends a bit what's the range, but it's always signed, so you always have negative values, and it's for float about 7 decimal places. And if you know float, so if you know we have a calculation which should be more precise than 7 decimal places, you can use a double. There you have about 15 decimal places, and that should be enough for most of the calculations, or I think for all of the calculations we are doing. Are there any questions in the chat about that?
what would you need if you would exceed this number? So I suggest
The long?
the long.
I don't know. I really don't know. Do you know it? There is actually one counter which counts time since I think 1970 in milliseconds, and this uses this long data type, and it is so it will end in 20 or 30 or 50 years. I don't know exactly, but the milliseconds from 1970 are stored in this variable here, and it's counting and counting, and it's incrementing for every millisecond, and it still has room in this long. So you will not need a higher address space or a bigger number for that.
At least not in this course. So
Yeah.
maybe in the future, who knows?
Maybe sometimes in the future, but this is maybe also an own field of study then.
Yeah.
Yeah, that's exactly the question what I thought. How would you store pi? Yeah, that's maybe one question for that, but I think it's not to discuss it here in our introduction to programming, how to store pi in this case. All right, we can also use a so-called sizeof operator in C, which gives us basically the size we saw here on the right side. And I defined here some variables, and then we can use this sizeof operator and write the variable name, and it will output us how big is this variable. So in this case, the character again 1 byte, the integer 4 byte, the long 8 byte, and the float 4 byte. This is very useful sometimes when you want to know how much space you need to store variables, but we will come to that later. I think it's in about a month where we talk about memory in general. But please remember the sizeof could be very important. And it will, I think we will use it from time to time because we will need it. All right. Maybe let's make a short cut here and talk about data in general. Maybe you experienced it also when you programmed the weekly exercises or tried something on your own. Sometimes it's not that easy to have just one variable for something. Data is sometimes a bit more than just a single value. Let's think of this, the flag of Austria. It's maybe not just one value, it has different properties. It is red, white, and red again. And of course, we can represent this using the RGB values, but it has 3 different values, or in this case, 2 different values. Or what about that? This is a geographic location on Earth, and it is a longitude and a latitude. So in German, a Längengrad und Breitengrad. And it somehow belongs together in this case. So of course we can store it in two different variables and it would work, but we know that they are somehow bound together and we want to store it somehow together. And this is when structs are now our helper to do that, because structs are used to group variables of a different type. So we can create our own data types now. We are not bound to only the characters, the integers, the floats and so on. We can create our own data type based on the combination of other data types. And that's very, very cool and very useful. Let's go back to this location where we have on Earth. So the longitude and the latitude, we know that each point on Earth has these values. So what we can do now is we create a struct called coordinates, and it has two member variables. So this is called a member variable, this is called the struct name, and it has two member variables. Once is the longitude and once is the latitude. Both are floats because of course we need decimal places for that, and we can bound them somehow together into like one variable.
Would it be possible to add even more member variables?
Yes.
For a struct?
You can make it arbitrarily long and arbitrarily big. This is just a very, very short example. Basically, you can also have just one variable and one member inside, but you can make it also with like 10 or 15. It is not best practice. Maybe you should then use more and other structs, but we will come to that. How can we write this now in the code? And you write it outside of this main function. You just write struct coordinates, and then you have this longitude and latitude values. And when you want to create such coordinates, you have to write struct coordinates. So this is the data type, as we have seen before when we write integer and then a variable name. In this case, this is the data type. This is my variable name, so I'm just creating a new coordinate data type and an object of that. And I call it Theograz because I want to store the location from Theograz there. And then I can access these two member variables using this point operator here. So I'm writing Theograz dot long is this value, Theograz.lat is this value, and now I have it stored. And the cool thing is I only have one variable here. I can access all the sub variables inside of this coordinate system by taking again this point variable, but the cool thing is I bound it somehow together into one variable, and that's very, very convenient because otherwise it can get very, very messy. You have a lot of member variables, or you have a lot of variables in your code, and you need to think how to name them, that you know that they're bound together. And in this case, it's better because you can bind it together into one variable using the structs.
Yeah,
Any questions?
We have one question that's a really interesting question in the chat. So would this be comparable to a class in Java?
Yes, to classes in general. Basically, structs are a little bit less, how would you say it? Yeah.
Less functional?
Less functional, yeah. But basically it is the same as a class, as you know, maybe know from other languages like Python, C++, C#, Java. They're all using classes, and structs are like lightweight classes. But basically it is comparable to that.
But you cannot have any functions or methods in a struct, right? So this is one limitation of structs.
You can, there are again some ways, but we will not discuss that. We will not discuss that. And we will talk about that later, also in the semester. But yeah, from now on, it is like a class for those who knows classes. All right. There are different other examples for structs, and hopefully you will also find something where you use structs. Also, maybe in the weekly exercises, there is something included where you can, or maybe should even, use structs. For example, you have a date. You can have a day, a month, and a year. Put it together into one date struct, and then you have just one variable. Or you have, for the mathematicians, you have a complex number, you have a real part and an imaginary part. You can put that together. Or you have just a point in two-dimensional space. You have an x coordinate and a y coordinate, and you can bound that together. By the way, in ESP, as you might have seen, we always use this underscore at the end of member variables, so that we know that this is a member variable. This is again our coding style, and please also do that, especially for the assignments, because there you should and you need to do it like this. There's one question. Does C have lists? Give us a few minutes and you will find it out. Yeah. All right. One more thing to structs. We already saw that the data type is struct coordinates, and that's fine. But wouldn't it be easier to just write coordinates, so we don't have to write this struct here always when I want to define a new object of this coordinate struct? And there is one way actually, and this is another keyword just called typedef. Typedef basically creates us an alias for an existing data type. So for example, we can write typedef unsigned char and then call it whatever we want. In this case, I want to call it byte. So I can now use the byte here as my own data type. So I don't have to write unsigned char. It is basically the same, but I can write and can name it on my own. Maybe it can be bound to the task I'm doing. So I can use my own name for data types. And this is very, very cool, because sometimes you have a lot of data types and a lot of data, and with this you can group them better, and you know, okay, this will be, for example, an unsigned byte will never be a negative number. Okay, let's make it unsigned char, and this is perfect, because then you can always write byte here, and it works pretty much the same. It is just a normal data type, and you can use it from now on, from there on. Please also always write it outside of the main function. And when we use this typedef also for our coordinates example, we have our struct here. Then we write typedef struct coordinates. We have here again the existing data type, and then the new data type here, so the new name of the data type. And then finally I can use just coordinates TO Graz, for example, as my new data type. Please also, maybe you can see here, we write it like this with this underscore in the beginning, in the end. This is just again a type of writing it in our case, because you cannot have here the same as here. It would the compiler wouldn't allow it. So we say, okay, we do an underscore here and underscore here, and this is the same as it states here, and then it works for the data type. I know it's a lot now for structs, and I will keep it like this. I have one more question in Slido for you. So it should be the same. If you still have it open, then go there. If not, you can rescan the QR code. What you have here is a struct with a student. A student has an ID, and this is an integer, of course, like the matriculation number. and we have a float, which is the grade point average, so the Notendurchschnitt in German. Then we say typedef, struct, student, student. Then we create a student, we call the student bill. And then we need here one more line. And in this line, we want to set the GPA, so this member variable of this student bill, to 4.2. What do you think is the right line to write it there?
Yeah, let's wait a few seconds. In the meantime, there's one, quite interesting question. Why do we even need structs? It's just more to write like it's.
You don't really need it, especially in the beginning, but it's convenient and you will need it later on. So we will come to more advanced topics and then we will need to use structs. From now on, you don't need it explicitly, but you have to learn it in the next few weeks. So we thought we will introduce it now.
And it will definitely help you, maybe even beginning from next week when we discuss functions. So you will definitely need it and it will help you.
How can we give our own typedef the wanted properties? So typedef is one simple command. It says always just typedef, then the existing data type, and then the new name of this data type. And implicitly, it takes all the properties of this existing data type and maps it to the new data type. So it's basically just another name you are defining for the same data type. Okay, I think we will now look at the result. Yes, it is bill.gpa underline is equal to 4.2. That's correct. But I just saw once again there is one error. I forgot the semicolon at the end. If that was the problem for you, I'm sorry for that. We won't grade that, fortunately. Yeah. But it is, as I said before, you have this student bill, then write dot, and then the member variable GPA underscore is equal to 4.2. And then you would need here a semicolon. I'm sorry for that. Yeah.
But as you see, this happens to us also, so yeah.
Yeah, I don't have a compiler in this app. I'm sorry for that, yeah. Then he would remind me on the semicolon at the end. All right, yeah, that was it already from structs and so on. I think you have also something to show.
I have something to show. Maybe it's a bit surprising to see a traffic light, but yeah, so we have now defined data types, we have variables, we have operators, so we could create our own program at the moment. And yesterday I walked through the city, wanted to cross a street, and then I stood in front of a traffic light, and then I thought, it's red, so I'm not allowed to go to cross the street, I have to stop. Green means I can cross the street, I'm allowed to cross the street, hopefully nothing will happen. But in my head it was like, okay, this is a condition, if it is red, I'm not allowed, if it is green, I'm allowed. That's a cool principle we could also use when we program, when we write our code in, for example, the C programming language. So we have a condition, depending if it is red, we have to stop, if it is green, we can go. So how can we translate this or this condition in the C into the C programming language? So we have a really brief example here. We have a traffic light code which is a character, and this can either be red or green. So the user can type in the console using scanf if it should be R for red or G for green. What we do next, this line, that's the interesting line in this code snippet. This is the if statement. So we need inside the brackets here a logical statement. So we have already learned about operators for comparison, so equal, not equal, greater or smaller, and also some logical operators, and or not, and so on. And what happens here is this condition is evaluated. If this condition evaluates to true, the code executed in this block, the code inside this block is executed, and if the condition evaluates to false, so this means also 0, the code isn't executed, it's just skipped. And if we now type an R into the console, then the traffic light code variable holds the value R. And as soon as the value is R, it equals to R, that's trivial, and then the code inside this block here is executed. So the principle of if and we'll see else and else if blocks is based on conditions that either evaluate to true or to false. And depending on the condition, a code is executed or not executed. So if we continue this value, continue this example and now have another value than R. So for example, I want to type in a G instead of an R, then this condition here evaluates to false. Why is it false? Because traffic light code holds the value G and G is not equal to R. So this part here is skipped, and then there is an else block which is executed whenever this statement here is not true. So if we type in a G, then this is not true, this is skipped, and we directly go into the else block and all the statements in the else block are executed. We've prepared another example because it's not always enough to have just one if and an else block. It would be cool to have multiple ifs, or we could also have else ifs. So let's say we want to guess the number of a person. So I imagine I have the number 3 and anyone else or other people should guess this number. If we now type in to the console the number 1, the number variable here holds the value 1. This is smaller than 3 and this is too low. So you want to give hints if it's too low, if it's too high, or if it's exactly the number we have in our mind. Okay, so if we type in 1, this evaluates to true, this condition here, and too low is printed. Now we want to have another case. If the number is equal to 3 or larger than 3, then we can just introduce an else block and this prints genius. But what if the number typed in is 4? That's, for example, not the number we had in our mind. So we need another block, and this is then called the else if block. And here we have another condition. In this case, it's number equal to 3. And only in this case, if the number is equal to 3, we print exactly. And in any other case, if the number is smaller than 3, we print too low. And if the number is larger than 3, we print too high. Okay, so we have 3 different cases in principle. That's really good. To practice this a bit, we have prepared another example. So this is...
I like it that you took our real ages.
Corresponds absolutely to the truth.
Yeah.
We have the age of David, which is 21, of course.
Yeah, sure.
And the age of myself, which is 23, more or less. And now it's your turn. Just drop in the chat what you think will be printed. Is it A, B, or C? So
what does this here and this here mean? Maybe let's go it once again.
So I would suggest to go through the first condition here. So the first if condition. This condition is actually separated into two sub-conditions, let's say. So the first condition here of the whole condition is David age less than 20. Is this the case?
No.
No, it's
No,
not.
it's 21.
You're
Yeah.
21.
So you're comparing 21 is smaller than 20, which is obviously wrong.
It is wrong, yeah. So let's take a look at the second condition here. The age of myself is smaller than 22. No,
It's also
that's
wrong.
not the case.
Yeah.
And this specific part here means or. So if any of the subconditions here, so if David age is less than 20, evaluates to true, or my age is less than 22, evaluates to true, then the whole condition here is true. But unfortunately, we are older than 20 and 22, so the whole condition here evaluates to false, and therefore this block here is skipped. Yeah, the chat.
Yeah, most of them recognize it, but let's go through it.
Let's go through it, yeah. So let's take a look at the next condition. We again have the first subcondition here, David age less or equal to 21. Okay, this is true, looks good, perfect. And we link this with an AND, a logical AND operator, with another condition. Sebastian age not equal 23. Okay, that's unfortunate because I'm 23. So we have one condition that evaluates to true and another condition that evaluates to false. And true and false is unfortunately false.
Yeah, so both have to be true. This should be, or so that is true. So in this case, it's not true, it's false.
So the whole condition here only evaluates to true if this condition here is true and this condition here is true. Of course, you can have multiple conditions linked by an AND operator, then all of these have to be true so that the code here is executed. Okay, if both are not true, then it's C.
Yeah, that's the else. Could we have more than just this three? So if else?
Yeah, sure, of course. We could have this. We'll see that in a few seconds.
Okay, let's move on.
Actually, if we want to print the day defined by a number, so the number 1 means Monday, 2 is Tuesday, 3 is Wednesday, and so on, we would have to have in total 1 if, 5 else ifs, or let's say 6 else ifs, and 1 else for any other number. Yeah, we could do that, but there are better solutions, I would say.
It's a lot to write, and it's always the same.
Yeah.
So yeah, there is like a special case for things like that.
Yeah. It's also not that beautiful, to be honest. If we just copy and paste this and just change the number and day. And for this we have, or C provides a very cool solution. For that we can use switch case. If you use switch case, be aware that it is only allowed to use integers and characters for switching and enums. So we have to define multiple cases, or we can define multiple cases inside the whole switch block here. What we do is we write case, then the number here, which corresponds to this here. So it would mean like if day is equal to 1, but we only have to write case 1, then we print of Monday. Then we have another case, 2, it's Tuesday, 3, Wednesday, and we could do it for all the other days. And that's very interesting here, we have a default case. So if none of the other cases are true or matched, then the default case or the statements inside the default case are executed. And now we have a very interesting question to you, chat. So what do you think will be the output for this code snippet?
So this is very, very important, and
Yeah.
it's still, so it's not that easy that you might think.
No.
Yeah, I already saw the wrong answer there, and yeah,
Oh, yeah.
grateful for that. I had this problem in the 4th semester in operating system, and it took me a day to find out what's the problem, because I fell into this pitfall.
It's a common pitfall.
It's very, very common. So the output actually is, maybe you can.
Yeah, we've already seen it in the chat.
Yeah.
It's Wednesday. Oh no.
But why?
It's-
It's case free. So what's the problem here?
Yeah, so if you use a switch case element in your code, you should, or otherwise you know what you're doing, but you should use the break keyword, because only if you use the break keyword, then the code, or you jump really out of this case here without executing any more following cases with its statements. So it's really important. In most cases, you will need the break at the end of the case. Just write break, and only the code executed in this case, only the code written in this case is then executed. So it's really important to write a break at the end of every case, unless you know what you're doing.
So if you don't have the breaks and you have the case 1, it will really print Monday, Tuesday, Wednesday, oh no.
Yeah, exactly.
So everything which is below.
Exactly, we'll go through all other cases or all statements
Yeah.
of other cases, and in this case, print the days and oh no. So that's really important to think of the break keyword in the break statement.
And we will also, maybe you also know the break keyword already from Python. It is the same, and we will also discuss it later when we talk about the loops.
Exactly. Yeah. Exactly. So
one more. Very, very interesting. I hated it in the beginning, to be honest.
Really?
Yeah, I hated it. It's so hard to read for beginners, in my opinion.
Yeah.
But we have to show it.
But in some cases, to be honest, at least in my opinion, it's really cool.
Yeah, it is cool when you understand it.
Yeah, that's true. So for this case here, it's quite a lot to write if you just want to print if the number is too low, so if it's smaller than 3, or in any other case, you want to print okay. What we could use for, let's say, simple programs or simple if-else statements, we could use the ternary operator. So the syntax looks a bit strange, to be honest.
Yeah,
especially at the beginning. That's true. It's
basically the same, right?
It's basically the same, just in another way.
In a very, very short form. Yeah.
So you have the condition here at the beginning. That's the same as the condition in the if here. This is then followed by a question mark. This is a bit strange, but
yeah,
you will get used to it. And this statement here is executed if the condition evaluates to true. And in the other case, if this evaluates to false, this is then followed by a column, then OK is printed. So this is just a very short form of this block here. So you can write if else just by using a question mark and a column following this syntax here. So we also have it again formally here, condition, then the expression if the condition is true, and separated by a colon expression if the condition is false. As we said before, please use it just for simple operations, because otherwise you will not understand it when you look at it.
We also will not understand it.
Yeah. Anyone else will not understand it. Yeah.
But I just saw one comment. It is a bit like the Excel if statement.
Yeah.
And it is like that. So yeah.
That's true. Yeah,
that's true.
Absolutely.
Yeah. All right.
But only for simple operations. Otherwise, it's
that's true. Yeah.
The same for Excel. So.
That's why Excel is such a strange thing, because it's so complicated if you have more than one if statement. Yeah.
Okay, that's great. And Before we continue with the next control flow element in C, we want to give you a brief introduction into arrays. We will learn a lot more about arrays in 2 weeks, I guess.
Yeah.
It's 2 weeks.
Yeah.
And so today it's really just a very brief introduction. So what are arrays? Arrays are a special way to store multiple values of specific data type in a contiguous block of memory. So you can have, in this case, 4 integer values, which are in a contiguous block. So we have first the number 42, 0, 11, and 72, and you can access these numbers, these values, just by using an index. So if you use the index in the position 0, it's 42, and if you use the index on the position 1, it's 0. So we've already had it today. So 0, or we start counting by 0.
Yeah, we always do.
We always do. And this also applies if you want to use arrays. So we always start counting by 0. So 0 means 42 in this case, 1, 0, 2, 11, and 3, 72. And how does this look like in C? Yeah, we define a variable of the data type integer, and we can just initialize it by using this index. So if we write numbers at the position 0, we can assign the value 42. Numbers at the position 1 is 0, and so on. Yeah, there are many ways to initialize an array. We will see that in 2 weeks. And how can you access arrays or values within an array? It's really similar to assigning a value or the initialization. It's again just by using an index position. So if you want to access the first value of the array, you just write numbers at the position 0, and yeah, you can then, for instance, just compare it to another value.
I have a question. We heard before about structs, which are also like combining more values. What's different now with arrays?
You can just have one data type so you can just have this data type here, values of this data type stored in the array. So it's not possible to mix different data types in an array. You can just have one data type. Exactly.
So all the numbers have to be integers inside.
Should be integers, yeah.
In the struct, I could mix, for example, a character with an integer.
Exactly, yeah.
Okay.
Can mix different data types in a struct, but here it has to be the same data type. Okay, so what if we now want to print the numbers of this array? So we have 4 numbers in the array. We can just use one printf and access the elements at the position 0, 1, 2, and 3. Okay, yeah, this is cool. We can do that. But what if we have an array that has 100 numbers, 1000 numbers, or I don't know how many numbers?
That's a lot to write.
That's a lot to write. I would not have that much fun, to be honest, if I would have to print all of them manually. Yeah, but what can we do? We can use loops. We can use a control element that is mainly used for repetitive tasks. We could use a for loop. We could use a while loop. Okay, so let's dive into loops in C. Let's have first a look at while and do while loops. These are 2 type of loops that are mainly used. We have a for loop, but a for loop is just another representation, an alternative representation of a while loop. So we can see both the while and do while loop start with have a start. However, there is a difference when it comes to the next element. The while loop always starts with a condition. So a condition is checked, and if the condition evaluates to true, then the task inside the while loop is executed, so any statements inside the while loop are executed, and once they are executed, it returns to the condition, and again the condition is checked. So this is then one iteration. Once we start with the condition check, then doing the task and going back to the condition check. Yeah, once the condition evaluates to false, we just go to the next task, so that comes afterwards of the while loop. And the big difference to the do while loop is that we start here with the task inside the loop. So the code that is written, or statements that are written inside the do while loop, are executed, and after all statements are executed, the condition is checked. So this is swapped here. So first we have the condition check in the while loop, and then the execution of the task. And in the do while loop, we first have the execution of the task and then the condition check. And once we get to the condition check, again we check if the condition evaluates to true. If it evaluates to true, then the task is again executed, and if the condition evaluates to false, then we go to the part after the do while loop. In German we also call a while loop a kopfgesteuerte Schleife and a do while loop a fußgesteuerte Schleife. Okay, then let's take a look at an example. So again we have an array here of 4 numbers, so we have 4 different values. It's the same for both here, and we have a counter that starts with 0. Okay, let's start with the while loop. We have the keyword while here and the condition here. So while the counter is less than 4, then these 2 statements are executed. So we start with the check of the condition here. Counter is 0 at the beginning. Okay, 0 is less than 4. Perfect. We go into the block here and execute the statements. So it's the first number that is printed is 42. We increase the counter by 1. It's the post increment operator we heard about last week. And we return to the check of the condition. So counter is 1, 1 is less than 4. Perfect. We print numbers at the position 1, which is 0. Okay, 0 is printed. Perfect. This then goes on until counter reaches the value 4. And once it reaches 4, 4 is not less than 4. Okay, then this part here is skipped and everything that comes afterwards is executed.
Here you can see something very, very important, because as you now can see, we are accessing here the array at the element of the 0 element, the first element, the second element, and so on. But we are not using the actual value 0, 1, 2 here anymore, but we are taking another variable as our counter variable to count through this array here. And this is very, very common. I know it's a bit confusing in the beginning, because you have here a variable defining the array, and you have another variable here, but just think of what values do this counter variable have here. It starts with 0, it's getting 1, 2, 3, 4, and then it's over because the while loop is over. So it's basically the same as writing here really just 1, the next iteration writing there 2, and so on.
Yep. Exactly. But we wanted to get rid of the magic numbers that were written here.
Yep.
And so we now introduced the counter variable you have mentioned. And this is now used to access the elements at a specific position without copying or rewriting the code for using it 4 times. So
one question from the chat maybe. Does the ++ just add a number so you can go through each iteration one by one? Yes, so this ++ counter means it just increments the current value. So in the beginning it's 0, ++ means it's getting 1 now, and in the next iteration it's getting 2, and so on. So whatever value is there in the counter, it will be incremented by 1.
what would happen if we wouldn't have this statement here? It would be quite unfortunate, right?
That would be very unfortunate, because then we have a loop which never ends, because the counter always stays 0, so it never reaches this condition to break out of the while. So this is then an infinite loop, and it kind of breaks your program because it will never stop, and you should avoid that. Usually you can close the program then, but your computer is running a program which you should not run in these conditions.
However, it will likely to be happen to run into this infinite loop. So it will happen. I ran into it 2 weeks ago. So it
is very, very common.
Yeah. But you will notice once you run into it. Okay, then let's continue with a do-while loop. So instead of writing while and the condition here, we write do. This is then followed by the block that should be executed. Again, we have here a print of the number at the position where the counter is, and we increase the counter. And now, very interesting, at the bottom of the loop, we have while and the condition, and this is then followed by a semicolon. So this is very important. Here we don't have it, here we have to write it.
So this is basically the same output, isn't it?
It is.
Why is there a difference between while and do-while loop then?
We'll see it in another example.
I should have a look at the next slides before I ask.
But that's a very good question, why we even need this, or what's the difference between these two. So just a quick explanation here. We go into this loop, execute these statements here, and only after that the condition is checked. So this is the main difference. For the while loop, we check the condition first, and for the do-while loop, we check the condition only after the code is executed once already. Okay, so here is the example. Maybe we have time for the chat to try to guess what the output would be.
Any ideas what's the output on this example?
So we have a variable that holds the value 5 and the condition while x less than 5, print x.
No output.
Yeah. Looks good.
Yeah, so there's basically no output because the condition is never true. X is 5 already in the beginning, so nothing happens.
Exactly, yeah. So what if we do the same thing now with a while loop, do-while loop? What will be the output here? Is it again nothing?
Remember the difference, so the do-while does something different.
Yeah, perfect. Looks good. So it's just one single 5 that is printed. Why is it printed? Because we enter this block here once without checking the condition. Then x is printed, and only after this statement here is executed, the condition is checked. And x is 5. 5 is not smaller than 5, so we do not go back here at the beginning of the loop. Instead, we just execute the code afterwards. So it is printed once because the condition is only checked at the end of each iteration.
And sometimes you have a task which should be executed at least once, and then the do-while loop will do the trick for you.
Yeah, exactly. Yeah. Okay, so we have already talked about the break keyword or the break statement. Why is this necessary? So, for instance, we want to loop through the numbers 0 to 5, or 1 to 5 to be honest, and we want to skip the do, or we want to break once the number is 2. What we can do here is we can just add a if statement with the condition if number is 2, then break out of the loop and do nothing else. And we want now to highlight the difference between break and continue. If you use break, you really jump out of the whole loop and continue here after the loop. So it's similar to the switch case. It's basically the same break, but the principle is like the switch case break. Once you write a break, you jump out of the loop, and this code here is not executed anymore for this iteration. And we also have the continue keyword or statement, which is used to break the current iteration. So skip this part here in this case, but we don't continue with the code after the loop. Instead, we go to the next iteration, which means we go to the next condition check. So in this case, we again have the condition if number is 2, then continue. But in this case, it's not a jump out of the loop, but it's just a skipping of the print of the number 2. So this is the main difference between break and continue. And yeah, again, as the do while, there are some cases where you can and will definitely use that. Okay, then as the last type of loop, we have the for loop. Yeah, the for loop is something special. We use it quite often, I would say, but it is a bit special. Or again, the syntax is you have to get used to it. We will see it on the next slide then. But before we have a look at the syntax, the difference between the for loop and the while loop is we have the possibility to have one statement or one expression to initialize something, or it is mostly used for initialization. This is only done once. So at the very beginning, before the first condition check, this is done once, but not in the loop again. Then we have the condition check. We already know that. If it is true, we do the task. And then instead of going back to the condition, we have one expression, we have one statement, which is mainly used to update something. We'll see that on the next slide, what it means. And then it goes back to the condition. And yeah, it's the same as for the while loop. If it is false, we do the next task. As long as it is true, we do the task inside the loop. So what does initialization and update mean? We have an example here with these three parts as the initialization, as the condition, and the update. So we want to print the square numbers of the numbers 0 to 4. We have a limit, this is 5, and as long as the numbers are smaller than the limit, this code is executed. So what happens here? Or maybe we could ask a chat what happens here. What is printed?
That's a lot of calculation
yeah.
So late in the day, but yeah. So at first the initialization is executed?
Exactly. This is executed only once. So we declare the variable here, we declare and initialize the variable here, and the very beginning of this for loop, it is only executed once. This statement here is executed.
Yeah.
Okay. So we want to print the square numbers. There we go. Okay, so we initialize current number to 0, which means current number holds 0. The condition is checked if current number is less than limit. Yeah, 0 is less than 5. Okay, we go into the loop and execute the statement here. We print square of 0, which is 0. Okay, this is done, but we don't go directly back to the condition here. Instead, we go to the update statement or the update expression. So we just say, okay, we want to increase current number by 1 by using the post increment operator. Okay, the update is done. We go back to the condition. So we check 1 is less than 5. Yes, it is. So we print the square of 1. Go back to the update, increment 1 by 1, which is 2. 2 is less than 5. Again, we go to this block, to the statements inside the block, print the square of 2. We're gonna increase the number 2 by 1. 3 is less than 5. Okay, print the square number. 3 is incremented by 1. 4 is less than 5. Okay, we print it again. And now our current number variable holds the value 4. We increment it by 1, which is 5. 5 is less than limit. Okay, we skip or we break out of the loop. The condition is not met anymore. And the code executed here is then, the code written here is then executed. And we've seen it in the chat.
Yeah, I saw it already a few times.
0, 1, 4, 9, and 16. Exactly.
Yeah. So this is a classic example of for loop, which we don't want to calculate or whatever. And we can do it using a loop from a start and to an end, to a limit. And we don't have to start with 0. We can also have the limits from 10 to 20, for example. Yeah. And we can easily modify this and change it.
Yeah, we can also do it in the other way. So we could start with 10 and have a limit of 0, for example, and also instead of having an increment here, having a decrement. So we could also reduce the number in each iteration by 1 and go from 10 to 0, for example. You could also use current number plus 2. So it's really up to you and up to the use case what you write in this section here.
All right.
Perfect.
Yeah, then let's go to our conclusion because we ran out of time. We are basically already over it, so sorry for that, but it is a very important topic. So yeah, what have we talked about today? So the size and the signs of variable are important. We saw that there are unsigned and signed variables. We have to take care that we don't run into the overflow or the underflow of variables. Then we talked about structs. Structs are a very cool way to group variables and to create our own user-defined data types. For that, we can use typedef. It helps us to create our own data types and to simplify the structure. Then Sebastian talked about conditions and conditionals in general. So if, else, the switch cases and so on. So now we can influence the control flow and control which part of the code is executed in which conditions. So sometimes I don't want to have a few statements executed and a few not. So we now can control that. And we talked about loops. So doing a repetitive task over and over again is very time consuming when we have to write it. And for loops, when we have a for loop, a while loop, or a do while, we can kind of automate it and write it in a very short way to count something, to iterate over an array, and many more things. So this is also very, very important for your assignments. You will have to work with conditions and loops, and you will also see it in the weekly exercises. There are also the examples with conditions and loops there, and this is very, very basic programming concepts, in my opinion, and you will have that on every other programming language. So you have to learn it, and it's very, very important.
So yeah, these are really the fundamentals of programming concepts. Using conditions, using loops. You will need it in all of the assignments. You will need it in many other programming languages. It's
and next week we already have our first assignment.
It's released next week. Yeah,
we will release it next week. So next week we have a few more very important concepts that we will introduce, and then you are already ready for the first assignment. It will be very interesting. Very looking forward to release it because it is very, very cool assignment.
Yeah. That's really
as always, if you have questions, you can on the one hand wait for the next stream, but I would highly recommend to practice on your own. Do the weekly exercise on GDB Also practice on your own if you want to have further further examples. You can do it on your own. If you have questions, check out our course website or raise them on Discord, and we are happy to answer them there. I think that's already it. Do we have any questions left in the chat?
I have tried to answer them in the chat.
Great. Then, let's go back to this view once more.
Yeah.
Thank you once again for being here. See you next week.
See you next week. Yeah.
Okay. Bye.
Bye.